Hello, my name is Leonard Walstad. I'm going to talk to you about loading data into Greenplum. We will use credit card fraud analytics as a use case to motivate this discussion. The use case is, given all the information we have about a transaction, is it likely to be fraudulent? We're going to address that question by training a model using the available data. It's been labeled. And then we will deploy that model into a production environment where it can be used in real time to actually score individual transactions as they are received. First, let's talk about how we load the data. So an application, credit card application in this case, puts data onto a Kinesis data stream, and a Lambda function takes that and forwards it on to a Kinesis delivery stream, which sends it to S3. Now, we have a Lambda function that monitors S3 and tells Greenplum it's time to load data from S3. Greenplum has a native S3 connector. That connector uses the backplane of Greenplum so that data comes into the database directly to the MPP segments. It's extremely fast, can load at hundreds of thousands or even millions of rows per second. Many of our customers use this. And it's not just for S3. Hadoop, all the other cloud providers, data storage systems are also available. File systems, we can also write data back out. We also connect to streaming systems such as Kafka, and we could configure it to connect with Kinesis. And if you wanted to do data science in Spark, we have a Spark connector that also both lets you read and write data back to Greenplum. So this is a great way for getting data in and out of the system and doing it very quickly. With that, let's transition over to a Jupyter Notebook so that we can see how this is done. So Greenplum's a relational database based on Postgres. I've already connected and set some parameters for the notebook and loaded some libraries. Let's talk about actually loading data into the data warehouse. So the first thing we're going to load is account and location information. These are the dimension tables, and the data is arriving as JSON. And the JSON conversion is shown here. This is standard Postgres syntax because we want to work in columns. So we're going to take it out of the JSON format that it's in our external table, which is referenced right here. And we're going to store it into columns. So this format, syntax rather, takes it out of the JSON structure and places it into individual columns. And we're going to do that both for accounts and then also for locations. So we'll go ahead and run that. And we've loaded a couple of dimension tables. That's great. So now let's load the transaction data. And this is where the power of our native S3 connector really comes in, because we're going to load a fairly large volume of data. In this case, it's in a CSV format. We support a wide range of formats, and it's extensible as well, so you can add additional formats as needed. Again, we're using an external table. Here, we're specifying the table is distributed randomly. Distributed randomly is always a reasonable choice. We can make other choices to optimize performance, but we can do that later. It's an MPP database. Redistributing the data is not difficult to do. And in fact, for the calculations, the data warehouse will automatically redistribute the data to get it in the right place to do the calculations you need. Again, let's load that. So at that point, we've just loaded about 197,000 rows, and the data is now in the data warehouse and is immediately ready to do data science. With that, I'll wrap up. Thank you very much.